Last time, we saw that two charged particles exert an electric force on each other. If the charges are both positive or both negative, then the electric force pushes the particles away from each other. If the charges have opposite signs, then the electric force pulls the two particles toward each other. This force becomes stronger if the particles move closer to each other and weaker if they move farther away. We can animate the motion of these particles by following a few simple steps. First, we calculate the force between them and evaluate whether this force is repulsive or attractive. Second, we calculate how much each particle's velocity will change by due to this force. This change in velocity happens over a small period called the time step. The smaller we make our time step, the smoother our animation will be. Third, we add this velocity change to each particle's current velocity. Fourth, we calculate how much each particle's position will change by due to this new velocity. Again, this change occurs over a small period called the time step. Finally, we add this change to each particle's current position. In this code, we'll animate an electron orbiting around a helium nucleus. When we create the two particles, we give each of them a position, a charge, and a mass. We also give the electron a velocity. To keep things simple, we'll keep the helium nucleus fixed in place for now, but you will animate its motion later. Next, this loop will carry out the steps of our animation as many times as we want. First, we calculate the force on the electron using the same electric force function we saw in the previous video. Second, we calculate how much the electron's velocity will change by during this run of the loop. Then, we add this change in velocity to the electron's current velocity. Next, we calculate how much the electron's position will change by. And finally, we add this change in position to the electron's current position. The resulting animation shows that the attractive force from the helium nucleus to the electron causes the electron to orbit around the nucleus. If we change the initial velocity of the electron, the shape of the orbit changes, but the force is always attractive. Now let's look at a different scenario where we have a helium nucleus, a lithium ion, and a proton. All three of these particles are positively charged, which means their electric forces will repel each other. Again, for simplicity, we'll only animate the proton and you will animate the other particles later. Notice that we use the same animation loop as before, but this time we must add two forces acting on the proton, one from the helium nucleus and one from the lithium ion. Keep this requirement in mind when you're animating the other two particles. As the proton approaches the helium nucleus, the repulsive force between the two grows dramatically, causing the proton's path to deflect away from the helium nucleus. The force on the proton shrinks back down for a moment before it's deflected again by the lithium ion. This animation shows you how dramatically the electric force changes with the distance between two particles. You have now learned how to animate the effects of the electric force. Follow the link in the description below to find a set of activities to help you learn more about motion under the electric force.